Okay, let's look at number 20 in section 3.3. We're going to calculate the derivative of this function. Now, when you look at it in this case, it looks like a quotient rule type problem. However, always ask yourself, can you simplify this first? And the answer is yes. And so we're gonna do that. We're gonna simplify this function first before I take the derivative. And it's going to turn out I will not use the quotient rule in doing that. So let's take a look. How can you simplify it? Well, remember, first of all, x to the 1/2 is the same as what square root of x is the same as x to the 1/2 power. So rewrite that. And what I'm going to do is, since I have a monomial, a single term in the denominator, I can rewrite this, first of all, right, by distributing essentially, right, because this x to the 1/2 is dividing each of these terms. Again, dividing by x to the 1/2 is the same as multiplying by x to the what? Negative 1/2, the reciprocal, right? And then multiplying, you would use the distributive property over subtraction and addition. So I'm going to divide each term by x to the 1/2. And then each individual term I can simplify, right? How do I simplify this first one? Well, remember the rule of exponents here. When you're dividing like bases to different powers, you subtract the power. So x cubed divided by x to the 1/2 is x to the 3 minus 1/2. 3 minus 1/2 is 5/2, right? Or 2.5, right? So this becomes 2x to the 5/2. Here I subtract exponents. 2 minus 1/2 is 1.5 or 3/2. So I get x to the 3/2. And then plus what? 6. 6 divided by x to the 1/2 is just 6x to the negative 1/2. So again, I'm dividing each thing by x to the 1/2. The same thing is multiplying each thing by x to the negative 1/2. But now notice I can take the derivative of this without any quotient rule. This is just sum and difference rule, constant multiple rule, power rule. And so I can do this, right? Here, the derivative for the first term, 2 is a constant multiple. X to the 5/2, I bring the 5/2 down. X to the what? Subtract 1, 3/2 power. That's the power rule. And then minus what? Power rule. Bring the 3/2 down. Subtract 1 from 3/2, I get 1/2. X to the 1/2. And then here, 6 is a constant multiple. Bring the negative 1/2 down. X to what power? Subtracting 1 from negative 1/2 is negative 3/2. We can clean this up now. Multiplying 2 times 5/2 gives me 5 x to the 3/2. Rewrite that. And then here, 6 times negative 1/2 is negative 3. Notice positive times a negative gives me negative 3x to the negative 3/2. And, that's a fine answer, I think. Sometimes I'll ask for you to write a result without any negative exponent. So how can you do this? Just this term here, right? We can rewrite this way, right? 3 times x to the negative 3/2. Remember, x to the negative 3/2 power is the same thing as 1 divided by x to the 3/2. So only this term is like this. It doesn't affect these other two terms. Now you could combine these all as one fraction, but we're not going to do that. This would be fine. But again, what's in red I think would be fine for achieve. Now, alternatively, you could use the quotient rule. I'm just going to show you that so you can get a feel for the difference. How did you feel about this? Does this seem easy to do? Well, let's compare this with using the quotient rule. So remember how the quotient rule works? I take the derivative of the top function. So the top function is 2x cubed minus x squared plus 6. So there that is. What's the derivative of that? Well, it's derivative of 2x cubed is bring the 3 down, 6x squared. Derivative of x squared is negative 2x, right? Got minus there. And then derivative of 6 is just 0. So there's the derivative there. Times the bottom function, which is the square root of x, or x to the 1/2, minus the top function times the derivative of the bottom function, all over the bottom function squared. Now, what's this derivative of the bottom function? Power rule. Bring the 1/2 down, x to the negative 1/2. So what do we have now? We do a little simplifying. Let's just go to the bottom. First of all, when I square x to the 1/2 or square the square root of x, I get just x, right? Multiply the exponents here. And then I got some work to do here. Notice this was the derivative. It's being multiplied by x to the 1/2. I have to distribute that x to the 1/2 over those two. So 6x squared times x to the 1/2. When I multiply like bases, I add the exponents. 2 plus 1/2 is 5/2. 6x to the 5/2. Negative 2x times x to the 1/2 is negative 2x to the 3/2. Okay. Now here you got to be careful too. Notice I am distributing this thing over these three terms, but also I'm distributing this -1 over these. So don't forget, you've got two distributed properties going on. So first of all, negative what? 2x cubed times 1/2. -2 times 1/2 is -1. And then x cubed times x to the -1/2. We add the exponents. 3 plus a -1/2 or 3 minus 1/2 is 2.5 or 5/2. So there's the first one. Then the second one, negative times negative is positive. So it's positive. X squared times 1/2 x to the -1/2 is 1/2. And then the exponents, again, we add 2 and -1/2 added together is 3/2. And then lastly, -6 times 1/2 is -3 x to the -1/2. Now there are some like terms up here I can combine. So 6x to the 5/2 minus x to the 5/2 is 5x to the 5/2. Okay, and then -2x to the 3/2 plus 1/2 x to the 3/2 is -3/2 x to the 3/2. And then I've got this -3x to the -1/2. Again, remember, it's always divided by x each time. So here's your answer. Compare that to what we got just a minute ago, right? What's the difference? Well, it's not quite simplified. So if you divide every term by x here, and of course, I bring this 2 down for this one, right? So 3/2 x to the 3/2 divided by x is the same as this. And then just simplify. Again, I put the x to the -1/2 is 1 over x to the 1/2 here. And so here, simplify, I get 5x to the 3/2 minus what? 3/2. Again, subtracting exponents, 3/2 minus 1 is just 1/2. 3/2 x to the 1/2. And then here I got x times x to the 1/2. Add the exponents. 1 plus 1/2 is 3/2. So here is the same answer we got from the other situation. Okay, so again, which one is simpler? I think if we simplify first, we don't have to use the quotient rule, and we get to the answer quicker, easier. You could use the quotient rule, but there's a lot of room for mistakes in that. So keep in mind, when you're doing the derivatives, it always is a good idea to see if you can simplify first. Okay, hope this helps.